For a long time, we've told ourselves a very specific story about science. It's a story of pure objectivity, of unbiased scientists simply collecting facts about the world, building an undeniable foundation of truth, one observation at a time. This story is powerful. It suggests science is a beacon of certainty, separate from human bias. But what if that story isn't entirely true? In his book, What is This Thing Called Science?, Alan Chalmers begins to unravel this idea. He explores a radical concept, that our observations are not pure, they are shaped, or as philosophers say, theory-laden. This means what a scientist sees is profoundly influenced by what they already know, what they already believe, and the theoretical framework they operate within. There is, as Norwood Hanson said, more to seeing than meets the eyeball. Think of it like this: two scientists can look at the very same thing and see something completely different. Let's take a famous example. Galileo, when he pointed his telescope at Jupiter, he saw moons orbiting the planet. This was a huge problem for the established Earth-centered view of the universe. But here's the crucial part. Galileo didn't just see strange dots of light, he saw moons orbiting a planet, because his mind was prepared by the Copernican idea of a sun-centered system. He interpreted what he saw through his theoretical lens. Meanwhile, his critics, looking through the very same telescope, saw something else entirely. Some saw optical illusions, others saw atmospheric distortions. Their deeply held Earth-centered theory would not allow them to accept the evidence. It wasn't a failure of their eyesight, it was a clash of theories. This is the power of a paradigm, a concept explored by Kuhn. Science operates within these overarching frameworks, like Newtonian physics or quantum mechanics, that define what counts as a legitimate question and a valid answer. For the most part, scientists work within these paradigms, interpreting data to fit the established model. But sometimes, the evidence builds up, anomalies pile up, and the old framework can no longer hold. This triggers a scientific revolution, a paradigm shift, where the entire lens through which we see the world changes. So, does this mean science is just subjective opinion? Not at all. Proponents of pure objectivity might point to our rigorous methods, controlled experiments, precise instruments, and peer review. These are vital. They help us minimize bias and build reliability. But they cannot eliminate the interpretive layer of the human mind. Our scientific knowledge is not a perfect, objective mirror of nature. It is a dynamic, evolving conversation. A conversation between what is out there and the brilliant, creative, and sometimes flawed human minds that are trying to understand it. It is a process of constant questioning, probing, and revising. Today's solid fact might become tomorrow's historical footnote, reinterpreted under a new light. This doesn't weaken science. Understanding this makes science stronger. It makes us more humble, more aware of our own biases, and more open to new ways of seeing. The power of science lies not in perfect, objective individuals, but in a collaborative, self-correcting process designed to challenge those very human interpretations. It is a messy, brilliant, and utterly human endeavor to understand the universe, and that might be a more fascinating story than the myth of pure objectivity ever was.